Okay, thanks for sticking around. I was kind of slightly daunted and looked around early, and the earlier session was kind of like full, but at least some people stayed, so that's awesome. So I'm Robin. I work for a company called Confluent. Just out of interest, who's heard of Confluent? Awesome. Who's heard of AWS? Who's using Kafka? Good stuff. Who's never heard of Kafka and kind of like forgot to leave before it was too rude? Okay, good stuff. So I'm going to talk. In fact, I'm going to try and nail my feet to the floor. I always wander around, but I've been told I need to talk into this. So we're going to talk about building streaming data pipelines using Kafka and using something called Ksql. Bit about me. I'm a developer advocate at Confluent. Before I was at Confluent, I was building data warehouses and data lakes and kind of analytics type stuff as a consultant, as a full-time employee. And that's kind of my background. I've been working with data and analytics type stuff for quite a while now. I love blogging. I've got my own blog. There's the Confluent blog as well. You'll see a ton of stuff there. I love tweeting as well. So if you do the Twitters, @Moff, that's me. Send me a tweet. The slides are on speaker deck. So let's talk about Kafka. People understand Kafka as being different things. Some people think of Kafka as pub/sub, or as an ingestion pipe, or as kind of like as a messaging thing. And in reality, Kafka is all of those and a bunch more. And the reason I'm kind of possibly seen as like splitting hairs over this is that it kind of matters a lot. Kafka itself is a streaming platform. And what we mean by that is Kafka has the ability to persist data, to provide the pub/sub capabilities, to do so at scale, and it provides streaming transformations on that data as it passes through as well. So it's a lot more than just pub/sub. It's a lot more than just like ingestion pipelines. And understanding that matters a lot because it enables us to actually build out some really good architectures built around it, instead of seeing it as like a little component in a kind of like a broader toolkit. It's a platform in its own right. So as I said, my background is in analytics, data warehousing, and stuff like that. And certainly the first time I came across Kafka, it's this streaming thing. And it's like, okay, I do analytics, streaming. Is this kind of like, is this for me? I'm quite happy with like my batch-based stuff over here. Like my data comes in, I stick it down somewhere, I process it, and then like, I'm good. I don't need streaming. But streaming's not just about real time. Streaming is actually for everyone. And the reason for that is streaming is about unbounded data. And all data is actually events. All data is events. So whether we're talking about kind of obvious events like streams of data from IoT devices and sensors, or your application logs are a stream of events. All the time it's like new events. These are a stream of events. These are easy to comprehend as events. But you also have business events. Someone phones up your company, they do a chat message, they buy something, they leave a review on your website, they do something, your inventory moves. These are all events. And then we also have events that come from databases. So a lot of data resides in databases, and databases themselves are also sources of events. So this kind of matters, again, in the same way of understanding Kafka as being this broader concept than just a specific thing. Kafka is a streaming platform. Understanding that events are the lowest granularity of data and actually underpin all data that we work with is important, because once you understand that, you understand why using a streaming platform is super relevant and powerful for whatever it is that we're building. So let's start off with an example of how a lot of people use Kafka. A lot of people use Kafka, certainly initially, and sometimes they get this far and then stop, as simply a dumb pipeline. It's like, hey, I've got some data in a bunch of log files. We'll stream it into Kafka and stick it in Hadoop or S3 or wherever we want to. And that's absolutely fine. That's great. Kafka is distributed. It'll scale out. It'll kind of buffer your data. It'll apply back pressure when it needs to. That's great. It's kind of source agnostic. All systems integrate with Kafka. Happy days. You can use it with a single machine. You can use it with machines, hundreds and thousands, whatever machines, nodes and containers, whatever you're using across your enterprise. And that's great. But it's just a dumb pipeline. You're kind of undervaluing what you can actually do with Kafka. Because if you think about what you do with that data once it gets down the other end of things. So once you get down to here, what are you doing with it? Now, some of the time you're just sticking it in a data lake and forgetting about it because someone said this is a good idea, you should build a data lake. But hopefully you're doing a little bit more than that. Hopefully, you're maybe analyzing it. So you take the data, you've streamed it into HDFS, and it then sits there. And then you pick it up again, and you process it for some analysis. And then you put it down again. And it's this idea of, we've got all this data, these events are streaming in, we'll stream them into HDFS, and then it's like, okay, now we'll just dump them, and batch process them, and like, well, that's okay. But actually, a lot of the processing that you're doing once it hits the other end, you can do as the data's passing through. So you can say, we've got log data that's flowing in, for example. That data, maybe you want to filter. Maybe we want to know how many errors are we seeing in our application logs. So typically, you'd have said, oh, OK, we'll stick it in HDFS, we'll run a Spark job or something, we'll process the files, we'll look for some errors. But why wait? Why wait until it's landed down there before you start to look at that data? Because actually, the freshness of that data kind of matters. So you can actually process that data as it passes through Kafka and say, let's look for any errors as they're coming in, and then either just pass through that data or split out the data. We'll keep all of the log data because that's always useful, but we'll also separately target the error data somewhere else. So already we've now got a fresh copy of that data ready to use for whatever we want to do with it. Maybe we want to do some analysis, maybe we want to stick it into an operational dashboard, maybe we want to drive an application based off that. But by splitting out that data, filtering the data as it passes through is a much more powerful way of doing things. So you can filter data using Kafka. You can aggregate data. You could take those errors and say, what's our error rate per minute or per 30 seconds? And you can actually do those kind of stateful aggregations as the data is passing through Kafka. But you can also enrich data. And this is where it gets really powerful. So here I'm talking about order events. For example, maybe coming from a microservice. But as I said, Kafka it integrates with all systems. So whether it's data coming from a log file, it's coming from a microservice, it's coming from a database, wherever your data is coming from, that can be used as the driver for this. So let's say we've got a microservice, it's responsible for placing order events. And those order events have got a customer. The customer's placed an order. But all that service knows about the customer is their ID. And to be able to do useful things with that data, send the customer a notification, do some analysis on what people have been ordering, what kind of customers order what, we need to know about the customer. We need to pull in the information about that customer. And so we have the information about the customer. Wrong slide. We have the information on the customer in a database. That's where we usually keep those things. So we can actually use Kafka to join these things together. As events are happening, the events flow into Kafka. We use Kafka to join that to other information. So as an order gets placed, take that order, find out the customer details, and create a new enriched message within Kafka. That can then be used to drive an operational dashboard, for example. It can also be used to drive other applications. And by moving that processing up the stack, rather than waiting until we've landed it down somewhere else and then enriching it, the same transformation that you'll do for one thing, almost certainly you'll do for another. Everyone wants to know about an order. Well, who was it that placed it? It's not just one application that will need that. So actually, by enriching that data as it flows through the system makes a lot of sense. We transform it once and use it multiple times. So it could be driving an application, it could be driving an operational dashboard, it could be also going down to kind of HDFS or S3 or whatever for our kind of longer term batch analytics. So let's build it. Let's see an example of it actually in action. So the example here, we're taking data that's coming from our website. So up here we've got ratings. So customers log onto our website, they say like, this product's brilliant or this product's awful, it's rubbish. And those ratings are from a customer. The customers, as I hinted at before, almost always sit in a database. So we can take information out of those ratings and we can join it to the customers. And that's useful for several things. We can find out which customers are leaving which reviews. We can say what kind of customers, maybe what their geography, are leaving what kind of reviews. And we can put this into a dashboard. We can analyze it. We can also use it to pick out some important patterns in the data. So imagine you're a business, you're doing the good thing, you're using the data available to you, and you say, OK, so it turns out that we keep on losing these really important customers. We've segmented our customer base. They've got a different status. We're bronze, platinum customers. So bronze ones, they're kind of new. Platinum, super important. They spend loads of money with us. They're our really valuable customers. The last thing we want to do is upset them. So what we could do is, as the data is coming in, as the review data comes in, we can find out who are those customers leaving those reviews. If a really important customer leaves a bad review, we can do something about that. The typical way of doing things, stream the data down to our data lake, do our analysis, find out a month later from our data scientists doing their data science thing that, hey, there's a correlation between important customers getting a bit upset and them never coming back is kind of strong. Why don't you do something about it? It's like, well, yeah, that was last month. That's no use now. The customer's been and gone, they're upset, they've gone somewhere else. Whereas if, as people are leaving negative reviews, we can find out, well, who was that customer? Hey, they're a super important one. Let's do something about that now. That's actually actionable. You can do something to actually retain them. You can phone them up and say, I'm really sorry. Can we do something about that to fix it? So we're transforming the data as it's passing through the system. So the data is coming through into Kafka. We're using the producer API from our website application. It could be coming from a log file or whatever, but in this case, we're using the producer API. We're using the consumer API of Kafka to consume the data into a push notification application. All of the code for this, by the way, is on GitHub. It's like, don't look at the push notification one. It's a horrible bit of Python that I've put together, but it works. And then to get the data from a database into Kafka, and from Kafka down to where we're going to build our operational dashboard into Elasticsearch, to get the data from Kafka down into HDFS or S3 or wherever for our kind of long-term analytics, we're going to use something called Kafka Connect. So just, everyone's kind of heard of Kafka. Lots of people are using Kafka. Who's using Kafka Connect today? 1, 2, 3. Hopefully I can kind of convince you otherwise. So what Kafka Connect does is it part of the Apache Kafka product, the API. And what it does is it gives you streaming integration using configuration files between sources of data into Kafka and from Kafka down to other targets where you might want to put that data. So instead of writing a program to take data from a Kafka topic and put it into Elasticsearch, or writing a program to take data from a database and put it into Kafka, instead use Kafka Connect. It's an API, it's a framework, you can extend it, you can create your own connectors, but it does super important stuff. It handles this centralized configuration of all your integration. It handles scale out, it handles failures, it handles schemas, restarts, all that kind of stuff that you're going to end up reinventing the wheel of if you try and code this yourself. So using Kafka Connect is dead simple. It's just JSON configuration files. As I say, there's an API if you want to go and write your own connectors, but there's hundreds of connectors already. So a lot of the time, it's just a case of picking your connector, setting up the configuration, and off you go. So you can stream data in from different sources into Kafka using Kafka Connect. Kafka Connect runs separate from your actual brokers. You can run it on a single node. You can run it on multiple nodes for resilience and throughput. And you can also use Kafka Connect for taking data from a Kafka topic, streaming it down to different targets. And then you can do kind of Kafka Connect for bringing data in and sending data out. So wherever you need to get data from other systems into Kafka, take data from Kafka into other systems, Kafka Connect a lot of the time is the right way to do that. You can use Confluent Hub for finding whichever connector it is you want to do and install it from there. Now, a really important thing when doing integration with systems is schemas. Now, I know schemas kind of like went out of fashion a few years ago. Everyone said, we're going to do schema on read. We're going to kick that can down the line. We'll make it someone else's problem. It's like, hey, well, who cares about schemas? Which is kind of cool and trendy, but actually really irresponsible. Because schemas and your data matter a lot. And a lot of the time, your data has got a schema. So it's sheer bloody laziness to say, well, I don't care about schemas. Schemas matter. And when you're using Kafka Connect, when you're using the Kafka ecosystem, the schema registry gives you a perfect way of handling and managing your schemas. So you can bring data in, for example, using Kafka Connect from a database, from wherever else, and you retain that schema. The schema goes into the schema registry. It serializes the message itself into Avro, which goes onto the Kafka topic. And then when you come to use that data, the schema is available in the schema registry. It deserializes the data, and it gives you the schema for the data. So you've got, if you're using Kafka Connect, you want to send the data somewhere else, you want to put it into a database, it will go and create the database table because it knows the schema. You're using your own Kafka application that you've written, you have access to the schema. So here we've got data, it's coming in from MySQL. We've got important things, we've got super important things. We've got date time columns. Date time's like one of the most awkward bloody things to handle when you're doing data interchange between systems. Is it a varchar? Is it an epoch? Who knows? It's a date time column. It's super important. We can't just use CSV or kind of like JSON with no schema. We need to know it's a date time column. So by retaining the schema, we keep that information. We know what the columns are in our data. We know the names of them, the data types of them. So when we come to use that data downstream in Kafka, for example, in Kafka Connect, we can go and create the target object. We can make sure we're streaming the data to Elasticsearch. We'll create the document ID, the document mapping, and make sure it's a date mapping that it gets. So when you're doing integration with other systems, make sure that you're thinking about your schemas. Even if you're not using Kafka Connect, if you're building anything, you should be thinking about your schemas. These are your contracts, your APIs between your different services. OK, so let's do a demo. So here we're going to take some data from a Kafka topic, and we're going to put it into Elasticsearch. Dead simple. So we're using the Elasticsearch sync connector. We're going to take data from a topic called LISA18, and we're going to send it down to Elasticsearch on that particular port. So let's, oops. I guess you can't see that. OK, at the back, thumbs up if you can actually read the text. Good stuff. So over here, we've got something called Kafka Cat. So people who use Kafka, if you've not heard of Kafka Cat's awesome. It's a command line tool for getting data in and out of Kafka. It's brilliant. It's kind of like Kafka Console Producer or Consumer, but more powerful. So I'm using that to send messages. And then over here, I've got Kibana that's just sat on top of Elasticsearch, doing a constant refresh of this particular index. So we're going to send some data. We're going to say, hello world. We're going to send a message to this Kafka topic. And over on the right-hand side, the left-hand side, hello world in our Elasticsearch index. Let's send another message. LISA18 is great, which it is. It's my first time here. It is awesome. OK, so straight away into the Elasticsearch index. So all we've done is set up that JSON configuration, most of which is just kind of like boilerplate. Take this Kafka topic, stream it to Elasticsearch. Message goes onto my Kafka topic up here, appears in Elasticsearch straight away. The next example helps us build out this kind of like this end-to-end example that we're doing. So here we're going to take data from our database, which has got information about our customers, and we're going to mirror that into a Kafka topic. So we're using MySQL here. It could be any relational database, MySQL, Postgres, SQL Server, whatever you want to use. And what Kafka Connect lets you do is snapshot all of the data that's there and stream it into a Kafka topic, but then take any change to that data and also mirror that into the Kafka topic. So here I'm using a tool called Debezium. It's fantastic. It's open source. It works with MySQL, with Postgres, with Mongo, and they're working on kind of SQL Server and Oracle and stuff like that as well. At the moment, generally, if you're paying for your database, if you're paying for Oracle, SQL Server, you'll often have to pay for your CDC tool. But Debezium works great with MySQL. So what we've got here is MySQL. It's a MySQL command prompt. We can say show tables, and we've got a customers table. From that customers table, let's have a look at the data. We've got some data. That's always good. So we've got things like the customer ID. We've got their first name, their last name, their email. And here's that club status, which is what we're going to use in building out this example. So ID 1, Rika Blaisdell. ID 2, Ruthie Brockhurst. So we've set up Kafka Connect. I'm going to just check that it's working. It's running. That's good. That means the demos stands a fair chance of working. And now I'm going to head to Ksql. I'm going to talk more in a moment about what Ksql actually is. For the moment, I'm just going to use it for interacting with my Kafka topics. So to start with list topics, let's check out the topics that we've got on our Kafka brokers. We've got one up here called customers. OK, let's have a look at that topic. And on that topic, if I can type, we have all of our customer data. OK, let me page up and find Rika. OK, here's Rika Blaisdell. So this is our Kafka topic. It's an Avro, because we're good. We're using our schemas. There's Rika Blaisdell, and all the information from that MySQL table. If I split my screen, And over here, on the right-hand side, back on MySQL. Left-hand side is our Kafka topic. Keep an eye on that. And what we're going to do is we're going to create a new customer in MySQL. So I'm doing a manual insert here. It could be an application interacting with a database, whatever. It's new data being created in the database. Insert into customers. There we go. And on the left-hand side here, we've got a new customer being created, ID 42, Mr. Rick Astley. I guess it should be Johnny Cash here, but hey. So here, new customer being created, mirrored straight away in that Kafka topic. So new data that we add to the database is now in that Kafka topic. But we can also change it as well. So we can say, let's change customers and change where customer ID is 1, set it to Bob. It was Rika as their first name, now it's Bob. And over here in our Kafka topic, we have the new updated record. So ID 1, first name Bob, last name Blaisdell. So it's got the rest of the payload of the record that changed. So using Kafka Connect, you can actually mirror what's happening in your database in real time into a Kafka topic. And that's super powerful because you can then use that Kafka topic to enrich data as it's flowing through our system. OK, so we've used Kafka Connect to pull data in from a database to mirror what's in the database, not just like a one-off batch load, but actually to stream in what's in the database now, plus every single change. It can also capture deletes, by the way, and it can show you deltas. So whatever it is that you want to do with that data, whether it's simply to provide reference data which you're going to join to, like here, or whether it's actually integrating with an existing system that you want to create a new microservice that's driven by changes upstream. Tell me whenever there's changes and I want to see the before and after records. Or someone deleted a record upstream, I want to be able to know about that delete and see what it was before we deleted it. You can capture all of that information and have it in a Kafka topic for you. So using Kafka Connect to get data from a database into Kafka, we're using Kafka Connect to take data from a Kafka topic, stream it down to Elasticsearch, stream it down to S3, down to Snowflake, wherever we want to stream it to. Now, let's actually do some stream processing. So Kafka, Apache Kafka, has got an API called the Kafka Streams API. It's a Java library. You can use it for writing Java applications, doing stream processing, using your Kafka data as part of your Java application. That's super cool. It's also super unhelpful if you don't write Java, like me. It's kind of embarrassing, but I don't write Java. But the good news is there's Ksql. So Ksql is built on top of the Kafka Streams API, so it's like it's a further abstraction on top of it, and it lets you use SQL for writing stream processing. It's super cool. So it's a declarative stream processing language. It's a streaming SQL engine for Apache Kafka. So it lets you interact with the data that you've got in Kafka topics. So you can inspect the data, you can filter the data, you can pick particular columns, but you can also write stream processing applications. And it's kind of so simple, it's quite easy to understate how powerful that is. So you want to write a stream processing application that takes our review data and filters out any reviews that are kind of not very favorable. So our reviews have got stars, 1 to 5. So 1 star as a product has been like 1 star. Maybe we want to know about that. Being able to filter that data in real time as it passes through, simply in SQL, that's really, really powerful. It's not like, and a few years ago I kind of got into the big data thing, but not knowing Java or Scala or whatever was kind of hindered. And then I saw these frameworks that came along. It's like, oh yeah, you can use SQL. I got super excited. But it was like, yeah, you can use SQL, but here's the boilerplate crap that you have to put around it to get it to work, which was kind of disappointing. But what Ksql gives you is a SQL interface. It's just SQL, and we're going to see that. So you can use it for things like real-time monitoring. Maybe you've got syslog data coming in from like thousands of different nodes. You want to filter that syslog data for particular events. So like, I'm a geek, I've got this running at home, obviously, as one does, and I've got a machine that's exposed to the internet. And it obviously gets a crap ton of kind of like login requests, people trying to brute force the SSH. So I set up a thing just saying like, take all the syslog data, there's tons of it obviously, and just create a separate Kafka topic showing any of these attempted logins. It's just a single statement, and that runs continually, and it populates a Kafka topic in real time with any of those messages that match those properties. You can use it for doing streaming ETL, which is kind of what we're doing in our example. We're taking our review data, we're joining it to information out of customers. You can use it for anomaly detection. So Kafka Streams, and therefore Ksql, support stateful aggregations. You can say how many messages have we received in a particular time window? What was the maximum value? What was the minimum value? And then you can build a predicate based on that. So you can say, we've got a Kafka topic. It's got credit card authorization attempts coming through on it. Let's group those authorizations by card number, and let's look how many authorization attempts were there per card within a 5-second window. And if there were more than 3, that kind of smells a bit fishy. Let's stick those onto a separate Kafka topic. That Kafka topic could be going to an operational dashboard. It could be driving a microservice, which is going to block the card or notify the cardholder. But that logic around the data, we're building into the stream processing within Kafka itself. If you use Kafka already, you'll be familiar with concepts such as replication factors and partitioning, and also the serialization formats that you use for your data. And you can use Ksql to actually manipulate your Kafka topics. You can say, I've got a Kafka topic at the moment, it's page view data, and it's in JSON. I ranted a little bit about schemas earlier. JSON's OK, but I prefer Avro because you have a schema. So we've got our data, it's in JSON, it's coming from upstream, they didn't know better, they were using JSON, but we want to re-serialize that into Avro to make life easier for people downstream who want to use that data. You simply say, select star from that JSON topic, and you say, well, I'd like to re-serialize it into Avro. And whilst we're at it, I want to repartition it to 4 partitions. It's literally select star. And that creates a new Kafka topic. As new messages arrive on our source one, we'll populate our new one, our Avro one with 4 partitions, with that re-serialized data. So Ksql is really powerful for doing lots of different things. So you build Ksql, you can do it from the command line, which is what we'll do. You can use a web-based UI as well for exploring it and prototyping the kind of queries that you want to run. And once you've created your queries, you end up with some SQL. Okay, it's Ksql. Before someone asks, it's not ANSI SQL. No, it's not, but it looks and smells like SQL. So you can then use this SQL and deploy it as an application. So your code that goes to production is a SQL file. You launch your production Ksql servers. You can run a single one. You can scale it out, obviously. And you pass a flag to it saying, use this query file. Here's my SQL file. There's no kind of gotcha. There's no like Java that you have to write or anything kind of like scary like that, or scary to me anyway. It's just SQL. You pass to it, and it runs that. Because Ksql is a continuous query language, you give it that statement, that create stream, select star from wherever, and it just keeps running it. It keeps on selecting star from it. OK, let's do another demo. So to start with, we're just going to take our ratings data, our review data that's flowing in. So up here, we've got things like the stars. I mentioned 1 to 5. 5 is really good. 1 isn't. What channel did it come in from? Did they use the web? Did they use the iPhone or whatever? And the message. It was really good. It sucked. I want my money back, whatever. So we're going to take that data as it arrives on the Kafka topic, and we're going to filter it. We're going to look at just particular fields within the data and just data that matches a certain predicate, where it's a less than 3 stars, where it's a poor rating. OK, so in Ksql, let's cancel that. And I'm going to have to use my cheat sheet, because otherwise I'll type it out wrong. As I say, this is all on GitHub, so you can go and find the cheat sheet and follow along if you want to. So to start with, we're going to register our existing Kafka topic. So our Kafka topic is called ratings, and it's an Avro, yay. And we're going to register it as a Ksql stream. I'm going to talk about tables and streams later, but for now we're using a stream. So we've created the stream. What we've not done is given any columns. But we don't need to, because we're good people, and we've valued our schema. So we've used Avro, so Ksql has gone to the schema registry and said, what's the schema for this Kafka topic? And it's given us it. So we can say, let's describe it, describe ratings. Hey, we've got a bunch of columns. Good stuff. So now we can do a select. So we can say, let's select certain columns from this stream. Okay, so select the stars, the channel, and the message from our stream of data where that predicate's true, where stars is less than 3. So now we're getting a real-time view of that Kafka topic. Kafka persists data. So if we want to, we could tell Ksql, like, rewind to the beginning of the topic and show all of the data that matches this condition. For now, we're just showing kind of the live stream of data. So this is our fictional users on our fictional website entering reviews in real time now. So that's useful. That's kind of like just from the command line. So we can view the data. We can start to get a feel for what does the data look and smell like. But even more useful is to persist it. And to persist it, all we need to do, create stream per ratings as. So hands up, kind of database people. Yeah, I used to be a DBA. It's not embarrassing. Databases are cool. So in the database world, you say create table as select. Create table as select something from somewhere. You create a copy of an existing table or a subset of an existing table. In the Ksql streaming world, you create stream as select. And when you create stream as select, you create a Kafka topic populated by the results, the continual results of a select statement. So we saw that select statement a moment ago. It keeps on going by on the screen. It's a continual query. It keeps on running. So now we're saying create stream per ratings as select. And the output, we don't get anything on screen because now that's running. Our application is built and running. It says the stream's created and running. Good stuff. So what it's actually done is it's created a Ksql stream. We know that because we can say show streams. It says you've got two streams. You've got your initial one, and then you've got your new one. We can say, well, OK, let's describe it. Describe per ratings. OK, it's got 3 columns plus a couple of system ones. It's got those 3 columns because that's what we defined in our select criteria. And it's an application. We can say describe extended, and we can see some metrics. How many messages have we processed so far? We processed 68. Let's run it again. We processed 81. So how many per reviews have we had that match that criteria? Stars is less than 3, 81. Let's run it again, 95. So this is an application that's running. And we can see that it's created a topic. We can say list topics. And up here is our topic called per ratings. We can use Ksql's print function. And the print just goes against the Kafka topic. Print per ratings. OK, there's our Kafka topic. I could use the Kafka console consumer or Kafka cat. It's just a Kafka topic being continually populated by this query. So if I wanted to deploy this to production, I would simply take that SQL statement, stick it in a SQL file, and pass it to my production Ksql servers. Simple. Now, let's go down a layer. Let's talk about stream table duality. So has anyone heard of the stream table duality? Tumbleweed. Stream table duality is a thing, I promise, and it's actually really, really interesting. So databases, there's a few people who own up to being database people. In a database world, you run a select against the table. And you think it's like it's a table. It's a static object. I run my select, I get my answer, it's a table. It looks and it smells like a table. But streams and tables are intrinsically linked. And they're linked by events. You know, I said at the beginning of this talk that all data is events. That's true. And we're going to see why. So the stream table duality is a thing. It's written about on our website there. And it's a super powerful construct. So let's think of a table. We've got a bank account or table, bank account ID 12345, select balance from account where account ID equals 12345. Your balance is 50 euros. Hey, why have I got 50 euros? I've got 50 euros because I deposited some money. I put some money into my account. I made a deposit, 50 euros. I deposit some more money. I put 25 euros into it. Now I've got 75. Select balance from account where ID equals 12345, balance equals 75 euros. Then I spend some money. Now I've got 15 euros. So on the right-hand side, we have the state of the key at a point in time. On the left-hand side, we have the stream of events. Okay? Stream, table, duality. They are intrinsically linked. You could take the table and every change to that table take as an event and store that event. You could take the stream of events and replay that to reconstruct that table. So, who is a DBA? Loud and proud, DBAs. Who used to be a DBA? Who's heard of the transaction log in a database? Yeah, loads of people. Hands up who think transaction logs are kind of important and fundamental to how databases work. Yeah. Transaction logs are a stream of events. Transaction logs are what you hope and pray you've still got when your database goes bang and you need to recover it and roll forward what's happened. Databases replay a stream of events to build state. So Pat Helland has this excellent quotation from his paper, Immutability Changes Everything. The truth is the log. The database is a cache of a subset of the log. All you need is your log of events, your stream of events. And that's what Kafka is. If you have your stream of events, you can rebuild your state. Okay? So why does that matter? Well, when we're working with our event data in our Kafka topics, our customer data is sat on a Kafka topic. A Kafka topic is a stream of events, but our customer data comes from a customer table. Huh? Well, we need a way to reason about it. So Kafka Streams API and Ksql have this concept of a table built on a stream. So what we're going to do here is we're going to take our customer data in a Kafka topic and we're going to model it as a table. So this is an implementation, this is a semantic. We're going to take our stream of data and we're going to tell Ksql, this is a table. I want to know what the value is for a given key, the state for a given key at a point in time. I don't want a stream of events. Well, maybe I do, but here we want to join to the value of a customer at a point in time. So let's see how that looks. Okay, so we've got our customers topic, back to our cheat sheet. So to start with, we're going to register that customer topic. So there's my customer's topic that's been populated by Kafka Connect, every change from the database. Okay, and we're creating a stream at this point called customer source. Okay, so from that customer source, we can actually query it. Okay, so show me from our customer stream any event where the ID is 1. So at the moment, we're talking about a stream of events. And there are 2 events for ID 1. There was the initial bootstrap where it was Rika Blaisdell, and then there was the update event where we changed the first name value to Bob. So we've got 2 events for our customers' data. Now, we're going to create it as a table. Okay, so first we create table created, and now let's look at what it tells us when we select from the customer's table for ID 1. It says the value for ID 1, the key 1, is Bob. It's not Rika, it's Bob. That's the current value, the current state of that key. Let's switch over to MySQL and just prove that it works. Okay, so in Ksql over here, let's update customers again. Let's change Bob to Fred. Keep an eye on the left-hand side because our table is about to emit a new state. So our table in Ksql has a new state. That key has changed its value. Okay, it's Fred. But this looks kind of weird because our table is supposed to give us the state for a key. But we've got 2 states. Why? Because Ksql is a continuous query language. The state has changed. It tells us the state has changed. If we rerun the query, the state for ID 1 is now Fred. So as your database changes, the state shown by Ksql changes as well. If we rerun it for the stream, okay, select from the stream where ID equals 1, we have 3 events. So the underlying Kafka topic is the same, but how we model it differs. So now let's join it, okay? I'm going to run create stream here in the interest of time. So create stream, ratings with customer data. This is a super useful topic. This is all of our ratings data, but now enriched with information about our customers. We're going to write it to a separate Kafka topic called ratings enriched. So we've overwritten the Kafka topic name, select rating ID and message, select a bunch of information about our customers. From ratings, left join to customers on user ID equals customer ID. Let's run that. Stream created and running. Good stuff. So now let's check ratings with customer data, describe extended ratings with customer data. It's got a bunch of columns here. Here's all of our different columns, the rating, the message, the customer full name, and so on. The queries that write to the stream, our application that writes to the stream, and then our metrics. How many ratings messages have we processed? How many are we processing per second? When was the last one processed? Let's rerun that. 10,000, okay, it's going up. It's a real-time application that's running. The last bit that we're going to do is we're going to create a second stream derived from that one just then, where we add on a predicate. So now we're going to build it against our ratings with customer data here, but now we say where stars is less than 3 and club status is platinum. Okay, these are our super important customers that are also a little bit pissed off that we're going to take good care of. So hopefully, if this has worked, there we go, it's worked, yay! So we have push notifications going to Slack, showing us in real time ratings that are coming in from our important customers that are upset. So whether you're using Slack, whether you're using whatever, our customer ops team can be on the phone to them now. Not like next month when our data scientists do their thing, but now. And then in Kibana, over here, we have our ratings information. So how many unhappy customers do we have? 45. Information out those unhappy ones. And then real-time analytics of the ratings data as it's flowing through the system. Okay, so 12:25, that's like now. I'm over time, nearly. Oh, no. But what are the different ratings channels that people are using to submit it? What are the different customer types that are submitting the ratings? Let's see the full information. So every rating that's coming in, which is like now, what was their name, their status, what rating did they leave? So this is using Kafka Connect to pull in the data from the databases. It's using Ksql to apply that real-time transformation to the data. It's using Kafka Connect to take that transformed data, to route it to Elasticsearch, to route it to wherever else we want it. OK, to quickly recap. It's all built on Confluent open source. So you've got the scheme registry, you've got Ksql. It's all built on the latest version of Apache Kafka. You've got the clients, the connectors, and all that kind of good stuff. You can ask me about the commercial stuff afterwards if you want. 3 takeaways. Kafka Connect for streaming integration. Kafka does stream processing. It does data persistence. It's not just kind of like pub sub. It's a whole bunch more than that. Ksql lets you build stream processing applications just using SQL. Free books, really, really solid, good free books. That QR code there will take you to the link. You can download those from our website. All the codes on GitHub, again, a QR code there. I'll share the slides afterwards. I'll put them on I'll upload the PDF and all the rest of it. And with that, I think I'm bang out of time, 12:30 exactly. Thank you very much for your attention. My contact details are there. I'll hang around now. Send me an email. Try it out. Thank you very much.